So when you start interpreting your expressions, it's really important to be very clear what the variables represent. And as long as you define things really clearly, it makes it a lot easier to interpret each of the expressions. When you interpret your expressions, you want them to make sense in a real world setting. So this company uses two different size trucks to deliver sand. The first truck can support X cubic yards, the second Y cubic yards. The first truck makes S trips to a job site, while the second makes T trips. What quantities do the following expressions represent in terms of the problem's context? All right, so this first one that we're looking at is S plus T. So if S is the number of trips that the first truck makes and T is the number of trips the second truck makes, then S plus T is the total number of trips taken to the job site by both trucks. Something like that. All right. This next one, X plus Y. So X is the number of cubic yards that the truck can take, the first truck, and Y is the number of cubic yards the second truck can take. So X plus Y is going to be the total number of cubic yards of sand taken in one trip by both trucks. So you have to be really careful here to say that it is in one trip because they can do more than one, but X is the number it can take in the first one. All right, now they're starting to get even more complicated. So here we're looking at X times S plus Y times T. So let's take each part separately. So X times S is the total amount of sand taken in one trip times the number of trips. So X times S, so XS is the total amount of sand brought by the first truck to the site. So in total, it's total amount. All right. And then, so then YT is the total amount of sand brought by the second truck to the job site. So XS plus YT is going to be XS plus YT is the total amount of sand brought by both trucks to the job site. Okay, so in all the sand that was brought total. All right, now when we look at the next one, we're taking that total amount, okay, of sand brought by both trucks, and we're dividing it by the total number of trips. So if you're taking the total amount of sand and dividing it by the total number of trips, what you're doing here is you're finding the average amount of sand brought in one trip. So this is going to give you the average, right? Average is when you take the total of everything and divide it by the number of trips, or like if this was a test, right? The top would be your score total for all of your tests divided by the number of tests gives you your average. All right, so that's how you do the delivery trucks and cell phones is next. So cell phones now is looking at F of T is the number of people in millions who own cell phones T years after 1990. So that's important to remember because we're going to use that when we're interpreting the different functions. So this first one, we're looking at a couple different pieces. So F of T equals 103 tenths. So the T here, t years after 1990, is 10. The 100.3 is going to be the number of people. So you can say this a few different ways. One way is to say 10 years after 1990, 100.3 million people owned cell phones. All right, but you can also interpret that. You can also say, what is 10 years after 1990? 10 years after 1990 is 2000. So you can say, in 2000, 100.3 million people owned cell phones. Okay, so either one of these would be fine. Right, and this next one, we have f of a, so we don't know how many years, but we do know the 20, so 20 would be million. So we would say a years after 1990, 20 million people owned cell phones. All right, and then C, now we have a number of years, but then not an actual number of people. So again, we can do this two different ways. We can either say 20 years, 20 years after 1990, B million people own cell phones, or 20 years after 1990 is 2010. So in 2010, B million people own cell phones. All right, and then this last one, we don't have any actual numbers, so we're just interpreting what the function is telling us. So this is telling us that n million people owned cell phones t years after 1990. So when you're doing these, it's important to keep track of what the variables are replacing and representing. Is it f of t, right? So f of t is the number of people, or is it t, which is years? Is it your input or is it your output? So keeping track of that is going to be really important when you are interpreting functions that have numbers in them.